All right, guys, we're going to go over some concepts from 1.4 talking about perimeter and area in the coordinate plane. So you've had a chance to already use your distance formula again from the previous lesson to calculate the distances of these lines, or these segments, I should say. Let's talk a little bit about the new concepts for this video. So the first one is talking about polygons, and you have some experience with this from your days in elementary school and middle school. So just a reminder again about a polygon is that a closed plane figure formed by 3 or more line segments called sides. All right, and the idea is that you have names for each of these types of polygons depending on the number of sides, and you know probably a lot of these. Once you get past the dodecagon at 12, you'll notice it says n-gon. So they have a little example here that if you have a 14-sided polygon, we would say a 14-gon. All right. One thing that you may or may not have learned in your days in middle school is talking about convex or concave polygons. The ones that you learn about in elementary school are all convex polygons. This idea that when you look at drawing lines through each of your sides, you never actually draw through the middle of the shape. But if I were to do that for this concave one, I'll do a different one. So here's another line from a side, and you'll notice we're going through the actual interior of the polygon. So that is called a concave polygon. One way that I try to remember it when I was in high school was, if you think about the word cave, or I'm thinking about going inside a cave, so if you draw that line and you go inside the polygon, that is concave. If you do not, it's convex. Okay, so let's do a quick little classification of these polygons, and we'll say whether they are convex or concave. So let's check the number of sides here. 1, 2, 3, 4. So that's 4 sides. If you need to refer to your table, you can. 4-sided polygon is a quadrilateral. And if you are looking for any of these sides, if you were to make them into lines, I notice that this one goes inside the actual polygon, right? So thinking inside the caves, this is going to be concave. Let's look at the next one. The next one has 1, 2, 3, 4, 5, 6. So that's a hexagon for this polygon. And if I were to try to draw any lines here, I'm not ever going to be on the inside of the polygon. So this is going to be convex. Okay, now let's do a little bit of, we'll do an example of finding the perimeter of a polygon and then the area. And these I put here as a reminder from your days in middle school to help you with these formulas. The idea for the perimeter, we're going around the polygon, and the area, we're counting how much area inside of it. All right, and some of these I'm hoping you remember, if not all of them would be great, but we'll go through how to find the perimeter and area using the coordinate plane. All right, so let's start with a triangle, DEF. So I'm going to plot DEF, so 1, 3 is point D. 4, -3 is point E, and then point F is -4, -3, that is point F. So we have F, -4, -3. D up here was 1, 3, and this was point E, which is 4, -3. So if I make this triangle, a reminder again, we're finding the perimeter, so we need to find the lengths of each of these sides and then add them all up. Now, one thing I noticed, which is nice, is that one of the sides is horizontal. So if you have a horizontal or a vertical side, then you can just count. So if I just count here from this side EF, so 1, 2, 3, 4, 5, 6, 7, 8 units. All right, so I'm not going to use the distance formula for that one since I can actually just count, but I am going to use the distance formula to find the length of segment DF or side DF, and then also my side length DE. Need to find that distance as well. So using the distance formula, you've had lots of practice with this. I'm going to start with DF, so the change in my X values is going to be -4 -1. We're going to square that, plus the difference in the y values, -3 minus 3, and we're going to square that. So when I get those two numbers, -4 minus 1 is a -5. Squaring that is 25. -3 minus 3 is -6. Squaring that is 36. So that's going to be the square root of 61. Let's get an approximation for the square root of 61. An approximation for the square root of 61 is 7.8 to the nearest tenth. So that is our side DF, and that is how long that one is. So if you wanted to write it, you could. Approximately 7.8 units. Now we do the same thing for DE. I'm going to do my change in my x values, which is 4 minus 1, all of that squared, plus -3 minus 3, all of that squared. So 4 minus 1 is 3. You square that, you get 9. -3 minus 3, we just had that one previously. That's -6. Squaring that is 36. So this is the square root of 45. Getting an approximation for that, we get 6.7 to the nearest tenth. So now I have 6.7 over here. So now that I have the distances for each of these sides, I can go ahead and find the perimeter by adding them all up. So the perimeter of triangle DEF is going to be approximately 7.8 plus 6.7 plus 8. So when you get that approximation by adding those together, you get 22.5 units. All right, so that is how we find the perimeter in the coordinate plane, using that distance formula, and then using our understanding of perimeter of a triangle is adding up the lengths of all the sides. Okay, let's do another example. This time we're going to find the area. All right, so we'll end up using one of our area formulas on the previous page. Let's go ahead and get this onto the coordinate plane. So we have the parallelogram J, K, L, and M. So J is -3, 5. There's J. K is 1, 5. L is 2, -1. And then M is -2, -1. So this one was J. This one was K. This one is L. And this one is M. Making this polygon, you'll notice we have a parallelogram. And if we look at the formulas for the area of a parallelogram, we have area equals base times height. So I just need a base and I need a height. All right, so I'm going to go ahead and count right here from M to L, which is 1, 2, 3, 4. So my base is going to be 4 units. And to get a height, I'm going to look at this vertical distance. So that's going to be counting 1, 2, 3, 4, 5, 6. So that's 6 units. Using my formula for a parallelogram, which is base times height, I can multiply 4 times 6 and get 24. So the area of parallelogram J, K, L, and M is 24 square units. Notice I use squared because we're multiplying these lengths. So when you use have a unit, in this case I don't have a unit, but I'm saying that the area would be squared units. Okay, so that's it for this. There's some more practice problems on here that you'll get a chance to try, but refer to this video if you need any help on finding the area, the perimeter, and then again discussing polygons and concave versus convex. Good luck.